Hi there. Let's make a start. Thanks everyone for coming. I'm not quite sure how I follow that keynote, but yeah, it's great that you're all here. I know there's a lot of choice, so I think you're in the right place, but I'm a little bit biased. So that's me, only a lot bigger. I'm going to start by running through a bit of an introduction to industry standards and the OWASP project, the OWASP Mobile Top 10. After the introduction, I'll then dive into some specific ways of mitigating some of those threats. There are 10 of them. I've got 45 minutes. There won't be time to go into actually that many of them. But you'll be pleased to hear there's a lot of other security talks, as you may have already seen, and the other security talks kind of plug the gaps that will be left by this. So if you take these top 10 as a framework, I'll give you some, and then you'll be able to get the other information elsewhere. And finally, I'll leave you with some pointers if you want to take things any further. So first of all, what are these standards? I want to look at it from two different perspectives to start with. The perspective of an app developer and the perspective of a CIO or a CTO. So first of all, how many app developers are there in here? That comes as no surprise. So I'll do that first. Picture an app that you've written, that you're currently working on, that you're thinking of working on. You might have a high level of confidence that it's secure, or you might not. Your confidence might be justified, or it might not. And ultimately, especially in the enterprise space, your goal will be to first establish that confidence yourself, and then find a way to accurately convey that confidence to your client and have them share it. So how can you do that? Well, yeah, that basically means how can you prove it? And what steps will they need you to take in order to prove it? So the only real way to do that is to work to a predefined, peer-reviewed set of standards. So we then switch over to the perspective of a CIO or CTO. Now, how many of those do we have in the room today? Yep, I thought there'd be a few. So you represent an enterprise having an app developed. Maybe it's internal, maybe it's outsourced, maybe it's contractors, whatever. But you've got to clear it from a security perspective. And if there's a breach 6 months, 12 months down the line, your decision might be questioned, and you've got to be able to show that it was the right decision at the time. So how do you approach that? Well, you'd find yourself in one of two situations. The first one would be your organization already has a defined set of security standards. If that's the case, fantastic. Stick to those. You should be fine. A lot of companies don't. A lot of companies still are going through their first foray into mobile apps, and that's a scenario that will continue for some time to come. So again, there, you need to fall back onto a predefined, peer-reviewed set of security standards. So, what are these standards I keep talking about? First of all, how many people are already familiar with the OWASP project? All right, awesome. That's quite a lot of you. I first came across it looking at the OWASP Top 10 for web. It's going back quite a few years now. I was working on a mobile app, got told I had to comply with some security standards, asked what they were for mobile, and received the web Top 10. So had to go through and kind of figure out which ones could be applied, which ones couldn't be applied, and meet them as best I could. Fortunately, things have moved on since then, and for a while now, we've had an OWASP Top 10 specifically for mobile. Now, I've got 2014/2016 there. The current kind of production-ready list, if you like, at this point is still the 2014 list, but there is a release candidate list for 2016. So the talk is going to go through the 2016 list because it's that much more up to date, but with the caveat that it may still be manipulated a little bit before it's finalized. Beyond that, you've got the catchily named OWASP Application Security Verification Standards. If I reference that again, I might just say ASVS, but that's what I mean. That's quite a comprehensive document. Chapter 17 covers mobile. With version 3, it kind of spread the information out a little bit more, so you can't get away with reading only Chapter 17 for mobile anymore. But 17 is the one that you'd be interested in. But the bulk of this talk is going to be looking at the top 10. So this is the top 10 list for 2014. Don't worry too much about scribbling it all down or getting a photo because it's disappearing in. I'll wait for the phones to go down. It's coming back in a second. That's the 2016 list, and there it is back again. So the first thing I'm going to do is just have a bit of a walk through what's changed between these two lists. So the first one from the 2014 list was weak server-side controls. It was potentially arguable whether or not that belonged on a mobile list because it basically pertains to your web backend. It was put there in 2014 because at that point it was the most prevalent breach found from mobile apps. In my opinion, I think that's correctly been removed from the list now. There's some hints of it that remain, but basically that should really be covered by the OWASP top 10 for web. There's a few that come straight across fairly straightforwardly. Insecure data storage, that changes a little bit, we'll see in a moment. Insufficient transport layer protection, they're named a bit better this time around, but largely the same thing. And I'll dive into the detail of what each of these mean, and we can have this for reference. Unintended data leakage now falls under insecure data storage, and that's one of the ones that we will dive into in a moment. Poor authentication and authorization, those two things each now get their own category on the 2016 list. Cryptography comes across. Client-side injection becomes code tampering. Security decisions via untrusted inputs has a better name. Improper session handling is now covered by insecure authentication, and lack of binary protection comes under reverse engineering. Like I say, we'll dive into each of these in a moment. That leaves two brand new ones for the 2016 list. Improper platform usage and extraneous functionality. So before I go into each of those, when we've got such well-defined standards, we've got a top 10, we've got the ASVS document, why do common breaches still occur? Well, there's an interesting report that I read from ArcSan, who are the guys giving the Think Like a Hacker talk in a couple of sessions' time, which you really should go along to if you haven't seen it before. They did a report that found 92% of finance apps were not addressing at least two of the top 10. This is based on I believe, based on the 2014 list. There's an organization called the Ponemon Institute who did a report called The State of Mobile Application Insecurity. Now, it was done in February last year, so a little while ago, but they were looking at reasons for security failures, even though we have these defined standards. And some of these will probably look familiar to you. They did to me. So the first one is rush to release. You'll start off having all your brilliant ideas and secure coding practices, and then suddenly something changes or the scope changes, and you've got a deadline you absolutely have to meet, and someone says, no, we've got to be pragmatic, and something gets thrown out the window at some point in the hopes of putting it back in later. The only way to mitigate this, other than finding the magic way to manage all your deadlines perfectly, is to have those established secure coding practices, to have ongoing code reviews and some code metrics to try and measure against it. The next one they found was insufficient testing. Now, you could say fairly straightforwardly, to mitigate this, you need to test more. This was basically testing too infrequently and starting too late. Now, as you'll all know, within the Xamarin ecosystem, we've got a number of tools that help us get a bit more thorough with our testing and gradually build it up over time and have those tests run in an automated way. The key then is to try and build in some kind of security testing to that. The next reason they found was malware-infected apps and devices. To a large point, certainly in the enterprise space, this pertains to people trying to bring a jailbroken phone or a rooted device either onto the network or just run some enterprise apps on a device like that. And it really doesn't take much Googling to get a good feel for how creative people get when they want to do this. And the thing that really surprised me, actually, was the number of people I came across who were trying really, really hard to make their personal banking apps work on their jailbroken phones. Now, if there's anyone that thinks that's a good idea, you've got to come to the hacking talk a bit later. The next one's always interesting, lower security budgets for mobile apps. This report that I'm referencing found that on average about 5.5% of total mobile app development budget was spent on security. And if you compare that to some other areas of software development, that's not that much. There's also a perception that a security breach on a mobile device isn't as damaging as a security breach on a web application, for example. But I do have a reference to an example a bit later on that is specific to a mobile device and potentially damaging. So it's dangerous to overlook that. Lack of expertise was the next one. The way that you mitigate that, obviously, is to come and listen to a talk like this. Hopefully it helps. But just raising general awareness within your organization. Again, like I say, if you've got security standards, fantastic. If not, then come and start referencing all these OWASP documents and the OWASP projects as a starting point. And then the last one was lack of policies, which has the same solution. In addition to that, the OWASP documents identify a couple more common reasons for breaches. One is the assumption that the operating system covers all security requirements, which really means the developers are saying, yeah, I don't need to worry about security at all, which really isn't great. The next one is interesting to us. They list weaknesses of cross-platform development and cross-platform compilation as a potential reason for security breaches. And that pertains to not correctly using security features of each platform that you're working on because you're coding to a lowest common denominator, which leads nicely into the first of the top 10, improper platform usage. So that's the definition: misuse of a platform feature or failure to use platform-specific security controls. And they list a number of ways in which this can often be breached, including that last one, which would seem fairly simple. If you write an app that has nothing to do with location and you request access to location on the device, that's breaching this. Now, I'm going to walk through an example that was recently pointed out to me on Android from API 23 onwards, and that's use of the usesClearText traffic attribute that you can set in the Android manifest file. This is sort of similar to Application Transport Security, or ATS, on iOS 9, which allows the developer to specify which domains you're permitted to access over HTTPS. Now, I say sort of similar for a couple of reasons. Firstly, this is opt-in, so by default, it's set to allow clear text traffic. And the second reason is, if you set this to false, to say, I don't want to allow clear text traffic over an unsecured connection, that's great, you've set the attribute, but nothing else happens. You've actually got to check for the value of that in your code and code accordingly. That basically means it's possible to set this in your Android project and dishonor it in your code. And more interestingly, it's possible to set this in your project, code carefully and honor it in your code, and use a third-party component that dishonors it. But I'll come back to that in a moment. So the first point here is, how do you set it? So this is from Xamarin Studio, typical Xamarin Forms solution structure there. And we're looking at the Android manifest.xml. Now, there's no nice UI to set it, so you have to go and do it yourself. And like I say, don't make the mistake of thinking, okay, now I've set it, that's all I need to worry about. The next step, certainly in the Xamarin Forms structure, is to then expose that to your code. So I've got a bit of code here to show how I'd done it. This is based on using Xamarin Forms from a portable class library, jumping out to the platform project to figure out what the value of this is. So if the structure there that isn't familiar to you, don't worry too much. That's the critical part. So when you run your app on Android, it will read the value from the manifest file, and it will set that property in the network security instance. So what I was doing was, from a portable class library, wanting to check, if we're on Android, what's the value of this? So I'm just returning that as a Boolean. So that's got that value exposed to my code. Now, this is some code that might be familiar to you. Some of you might be doing this. Just creating a new web client and downloading a string, passing in a URL. It's not doing anything more. It's not checking what that URL is. And this will dishonor that setting in the manifest file. If you want to honor it, there's a couple more things that we have to do. So you see the two lines at the bottom, exactly the same. And here are the different parts. So first of all, we're honoring it. And then those checks are, the network policy service refers to the class that I had on the previous slide. So has that been instantiated correctly? I'm checking that because I'd be calling out via the Xamarin Forms dependency service to get that going. If I've got one of those, then look to see if I'm on an insecure connection. If I'm on an insecure connection, then check the value of this flag. If we pass all that, then we carry on. So now we've got some code that will honor that flag. Then we come on to taking a look at components. Here's a list of components that honor the setting, which means they do their own checking of it. And here's some components that don't, which makes life interesting. So if you happens to be specific to Android, this one, but you might find you have your work cut out security-wise there. If you want to dig any deeper into this, I've just got a link to the Sydney Xamarin user group there. We've got a number of presentations coming up fairly soon. We've just started recording them as well, so hopefully there'll be links to those if you want to take a look. If you do watch a video, just be nice, because we've only just started. OK, so that's a whistle-stop tour of M1 improper platform usage with one example. Now, in reality, probably each one of these top 10 could justify a presentation of its own. So I'll move on to M2, insecure data storage. Now, remembering from the 2014 list, this covers two. So if you're familiar with the 2014 list, this is where those two items have gone. So the old insecure data storage basically covered any data at rest on the device, including all of those. Unintended data leakage, there are a number of ways in which data can either inadvertently come out of your app, or maybe there's some malicious code to try and get something out of your app. So I'm going to take a look now at two of these. The first one will be the task switcher on iOS. Now, you're probably all familiar, I'm sure, with you double tap the home screen, the home button on iOS, you get the task switcher with an image of each application. iOS takes a screenshot of your application to do that. Now, in a lot of cases, that's fine. But if you're in an enterprise setting or you've just got some sensitive data displayed on the screen, you probably don't want that data to then be captured and held in a different part of memory on the device that's outside the control of your app. Now, there's an approach that we can take to mitigate that, and that's to intercept the point at which iOS takes that screenshot and give it something else to take a screenshot of. And then when we come back into our application, we've then got to correct things so the user actually sees the proper application again. A couple of points on this code. So here I'm overriding on-resign activation and on-activated. So these are the points at which the app ceases to be the current active application. So that's where the screenshot will be taken. And when it's activated, it comes back to being activated. If any of you have looked at doing this before, you might find, let's remind myself of the names, yeah, you might find people have used did enter background and will enter foreground for these. And they work almost all the time. The issue with those is if you're using did enter background, if you tap the home button once from your app, did enter background will fire. You'll go back to the home screen. Then you go to the task switcher, bring your app back into the foreground, will enter foreground will fire. If you're in your app and you double tap the home button straight away, on-resign activation does fire because your app is no longer the active application, but did enter background doesn't fire at that point. So if you're double tapping straight from your app, you would still get the screenshots without any changes. And likewise, if you go straight into the task switcher from your app, and then you choose your app and go straight back into it, will enter foreground doesn't fire because your app is still in the foreground. But at that point, on-activated will fire. You do have to be careful they're not activated because that fires in a lot of other places. So I'll throw up a little bit of code to go through each of those steps. So this first part is a few lines, iOS-specific lines, that will take a screenshot of your app. Just take an image of the screen and save it away in that image object. I'll wait until the phones go down. I think I'm right in saying you'll have full access to the presentations, and I'll make sure this code goes up on GitHub and the links get published if you don't get what you want. Once you've got that image stored away somewhere, you can then do some manipulation of it. So this will apply a blur to the whole image. Now, if there are any iOS graphics people in the room who are really hot on graphics, you may well have a better way of doing this. This just applies a simple blur to everything. It's interesting at this point, you could get a little fancier if you wanted to. You could say, well, I've only got certain bits of the screen that contain sensitive information. I only want to blur those and leave the rest intact. You could even then take that further if you've got a framework that you're using to find a way to identify certain UI fields or certain properties of your models as sensitive and have this code interrogate that and try and do something nice. In many ways, that sounds like overkill, but it could also give you something testable and auditable. But the approach I take is if you blur everything, then you know it's all blurred. Then once you've got that blurred image, the last thing to do is then put that over the top of your app. That then becomes what's on screen, and that's what the screenshot is taken of. That's then what appears in the task switcher. So the last step, if I jump back quickly, we've done 1, 2, and 3, so we've got the blurred image. It's nicely in our task switcher. Now when we come back into our app, we need to do step 4 to remove that blurred view. Now we're going to have to check in there whether or not we have added a blurred view already, because we don't want to just come back in and remove whatever the current view is. We get into all sorts of trouble. This is a fairly rudimentary way of checking. If you've got a complex UI structure, you might need to get a bit cleverer there just to make sure you're only removing something if you've definitely added it. So that's one example of unintended data leakage. And as you saw from an earlier slide, there are many more. So it's a topic you can dive into in a lot of depth. So I'm going to take a look now at the other aspect of insecure data storage, which is storing data in a SQLite database. The OWASP project, if you take a look at the website, there are quite a lot of cheat sheets. There's some really useful information in there, some really useful tips. They're not all completely up to date for the 2016 list, but if you find one that hasn't been written yet, oftentimes you can go back and look at the 2014 list and you'll still get useful information there. Points to note here, it does say on this cheat sheet, small amounts of consumer-grade sensitive data should go into the keychain. They reference things like authentication tokens, session IDs, and that kind of thing. But the fact that that exists as a recommendation for iOS potentially means that not doing that breaches M1, improper platform usage. I also found it interesting that it recommends the use of a third-party encryption API, and that quote, one that's not encumbered by inherent weaknesses in Apple's encryption. That was a specific reference to not just using a 4-digit code as your encryption key. It does then go on to single out SQL Cipher as an accepted method of encrypting data on the device. I just put a link there for Windows Mobile 10 for a similar guide for security as well. And I'll then go look at some code for SQL Cipher. So SQL Cipher is, how many people are already familiar with that or come across it? Okay, so that's open, the C code for that is open sourced, and there are some commercialized implementations of it. Oh, there we go. So I'm going to take a look at making use of that just briefly. There are components in the Xamarin Component Store. You can get hold of it for iOS and for Android and for the Windows platform. It gets a little bit interesting when you're trying to implement that in a cross-platform solution. So the code that I've got here is cross-platform Xamarin Forms solution and typical MVVM kind of structure. But because you've got references for the 3 platforms, you've got no reference to add to the portable class library, so you've got to get clever and jump out to the platform projects again. And that's because there's a dependency on system.security.cryptography, which isn't available in the portable class library, or certainly not the profile that I'm using here. So I've had to make a bit of a plan. First of all, you can't see anything. Fantastic. Okay, give me 1 second. I'll get that up on the screen for you. I'm just going to walk through. No, other way. Okay, I might need a bit of technical assistance. I'm just going to walk through the fact that I've added the components from the component store into the iOS project, the Android projects, and the Windows project. So it comes in as a component to the first two, but then just has to be added as a reference to the other one. Hopefully we're almost there. If not, I'll put this code up on GitHub as well, and you can come and grill me about it afterwards if you need to. Okay, so if I now... I might need to do this. No, other side. There we go. Fantastic. Thanks very much. That means it'll just take me a second or two longer to switch back. So in here, I've got the SQL Cipher component added for iOS, for Android, same for iOS, and added the reference for Windows Phone. So what I then have to do, so typically in an MVVM structured project, I'd have my views, my view models, all the nice things you'd expect in a portable class library. And I then have a collection of service classes. So for standard SQLite, I'd have a data service class that handles all the database interaction. Because I don't have a SQL Cipher component for the portable class library, I can't put that service class in the portable class library because it relies on the reference to the component. So I have to jump out and put that into the iOS project, for example. So I could go and put the service class in there, use the dependency service to jump out to that, and do everything I need to. It works really nicely. But then I've got to go and implement that for the other platforms. So when it comes to putting that into the Android platform, for example, I'd start implementing that service class and then quickly see, hang on, this code's identical to what I've put in the iOS project. It's not, in some ways, it's not platform specific. It's not doing anything platform specific. It's just using part of the .NET library that isn't available in the portable class library. So that then makes it an ideal candidate to have a mixture of PCL and shared projects. And I can put the SQL Cipher data service into the shared project, have a reference to that from each of the platform projects. I still use the dependency service to jump out from the PCL, and everything works nicely. I'll just bring some of this code up quickly. For those who are familiar with SQLite, which is probably a lot of you, a lot of the code will look identical. You can, to a large extent, you can rip out SQLite and plug in SQL Cipher, leave a lot of your code unchanged. So this is where I'm creating the connection to the database. And you can see again here, I'm jumping out to some platform-specific code. That's because, if I bring up the iOS version, for example, I'm specifying exactly where the file sits within the file system. This new SQLite connection is where I actually create the connection to the database. And the only real difference with SQL Cipher is you have this second parameter. Can anyone see anything wrong with that now? Plain text password just in the code. So this isn't designed to show you how to put the password in, how to specify the password. That comes under key management a bit later. But just to show you a method of getting SQL Cipher in to a portable class library cross-platform project. Okay, now bear with me a second while I switch back. Come on, you can do it. Let's try that. Okay, perfect. So that's covered M2, insecure data storage. The next one is M3, insecure communication. Now this covers a number of things, basically talking about data being transmitted between device and server. One of the interesting points I found here was it recommends looking out for clear text communication of sensitive assets. Now, depending on what jurisdiction you're working in the UK and I think in most of Europe, hardware addresses, the IMEI, the UDID, MAC address, and IP address are considered sensitive assets. They're considered personal information. So you've got to treat them as though they are sensitive assets, the same as you would any other personally identifiable information. I'm not going to dive into this one any more than that because there's going to be a great talk tomorrow from Kerry Lothrop on, I think it's called Is Your App Secure, which is going to dive into a lot of this, and I'm really looking forward to seeing some of his demonstrations. The one thing I was just going to show was a quick way of validating a certificate. So if you're using HTTPS, you can't just necessarily assume that that's sufficient. You'll want to validate that the certificate you're getting is exactly what you're expecting. And this is one way to do that on iOS and Android. It's basically tying into the service certificate validation callback of the service point manager, and then just checking those parameters that are passed back in. So taking a look at the SSL policy errors, checking that no errors come back, and then that next line is taking a look at the hash of the certificate and comparing it against that valid certificates, which would be a list of hashes that are acceptable. So just making absolutely sure you're getting the right certificate back. So insecure authentication. Those of you who did the training would have done some OAuth coverage, I think, yesterday. The basic rule for this is, in general, if you're doing a mobile version of something that's already on the web, you need to apply the same kind of rules. And specifically, it shouldn't be possible to authenticate on the device with less authentication factors than you're using on the web. Further recommendation is to never use one of those device identifiers to identify either a user or a session, remembering that they need to be treated as personal data in some jurisdictions. And these days, if that applies in a big jurisdiction like Europe, you probably want to apply it everywhere. There was a further recommendation which gets interesting. Avoid out-of-band authentication tokens being sent back to the same device as they were requested from, basically. So this would be an example of going onto your internet banking and requesting a transfer, and then some security kicks in at the bank, says, hang on, that amount is above a threshold, it needs authentication, I'm going to send an SMS authentication code to your phone. So you then pick up your phone, get that, key it in, transaction goes through. That's added a layer of security, because not only do you have to access your account online, you've got to have your phone in your possession, and you've got to be able to get in to access your phone. Gets a bit different when you're using your phone to initiate the transaction request, whether it's via the web or whether it's via an app. If you then get the token coming back to that device, it hasn't added anything like as much extra security. It's no longer out of band. There's an interesting usage of this that began a while back, but a recent incarnation of it attacked, I think it was a total of 20 banks they reported, but it covered the big four in Australia. And that was apps containing malware that were intercepting the SMS code coming back and forwarding it on to a malicious third party who could then have access to your bank account. Now that is a good, I should probably say bad example of where security is unique on mobile and critical on mobile. So the next one, M5, insufficient cryptography. And this can get very detailed and could be a whole host of sessions or by itself. Again, OWASP kindly provide a nice cheat sheet for us with some recommendations. One of the things that's interesting to see is if you're doing cryptography and preventing access like that, you need to make sure that that is active, even if the access controls fail. So even if some company somewhere manages to break your 4-digit PIN, They ideally should still not be able to get into the app and access your data. Those of you who did the Xamarin University training, I think would have been taken through use of the PCL crypto component. So I mentioned before that system.security.cryptography is not available in the portable class library profile that we tend to use. So you have to jump out to the platform-specific projects. PCL crypto is something that handles that nicely for you. You bring it in, it adds references to all projects, including the portable class library, and gives you a way of calling your encryption and decryption routines directly from your PCL, and it does the jumping out to the platform projects for you. We've mentioned a couple of times use of hardware identifiers, so the IMEI, the UDID, and being careful what you use those for. The SQL Cypher team have some interesting and kind of pragmatic advice around that. So as a general rule, you shouldn't use one of those as your encryption key. But what the SQL Cypher guys say is what's actually unacceptable is to use one of those in its entirety with nothing else as your encryption key. But they do propose that you can take one of those identifiers and use it as a portion of your encryption key, providing that there's another portion there that meets two requirements. It needs to be entered by the user, and it needs to be never stored on the device. Now, you can see from that, if you're thinking of practical applications of this, you will find a balance between security and convenience. And in some cases in enterprise, that ends up being a balance between security and business continuity. And it's not necessarily unusual to find a situation where maintaining business continuity is more important than securing the data on the device, depending on the processes and depending on the sensitivity of the data. But there are always interesting discussions to be had around that to get that tied down. Next one is M6, insecure authorization. So this is where we've separated authentication from authorization. Authentication being, are you really who you say you are? Authorization is then, okay, I believe you are who you say you are, now what are you allowed to do? A common breach of this, and this is where that first, the old M1 from the 2014 list, weak server-side controls, kind of creeps back in here a little bit. Because a common breach of this is where you have an app that is successfully authenticating, successfully authorizing, making the right functions available based on your privilege levels, and then making a call to a back-end web service. But the web service is not re-authenticating and reauthorizing to check that that request is valid. Now, you can't rely on that. I know we're all perfect coders, but sometimes the apps don't quite request the right thing. But even if they do, even if you could guarantee that 100%, you can't guarantee that your app hasn't been compromised, that the code hasn't been tampered with. So this basically points back to making sure the OWASP Top 10 for mobile has been completely applied to your back end, and you're not completely relying on the device to handle this for you. Okay, these last few, client code quality. This basically refers to any security problem where the resolution is to change some code on the device. And this refers to things like buffer overflows, maybe string formats, weaknesses, a number of other things. So this will be covered in more detail by Kerry on Thursday, and I believe the guys later today in the Think Like a Hacker talk may well be covering some of this as well. A similar solution for code tampering. So code tampering would be basically getting in and making some kind of dynamic change to your code, maybe dynamic memory modification. On iOS, it might be method swizzling, local resource modification while your app is running, just to change what's happening. Again, there'll be a lot more detail on that in the Think Like a Hacker talk, so I won't dive in too much. I have just put up a bit of code just to do a relatively straightforward check on iOS as whether or not you're running on a jailbroken device. All that's checking is whether or not the Cydia substrate exists on the device by trying to open a URL that begins with it. If that succeeds, your device is jailbroken. If that fails, you can't 100% guarantee that it's not, but it gives you an idea. So M9, reverse engineering. Again, I'm going to kind of pass this one over to Kerry for his talk tomorrow because I know he's giving a demonstration of this. But this is where you can take the binary and decompile it. An interesting application of that kind of applies to all of us is if you're writing a cross-platform app and you're quite rightly trying to maximize the amount of code that you're sharing, and then you're distributing securely for Windows, you're distributing securely for iOS, and you're distributing for Android. You can, it's not that difficult to go and get hold of the APK, take a look inside it because it's just a zip file, take the binary out of that, run it through a decompiler. There's quite a few free ones available. It doesn't take much to find one. And then you've got that back down to C# code. And where you've got that code shared across your apps, you've then got a lot of information about your iOS binary that you can then potentially use to try and engage in some code tampering. So that's one of the sides of the risks of that. The other one is, of course, leakage of intellectual property. The last one I've got then is extraneous functionality. So this was the other new one on the list for 2016. And this refers to things that are left in the app that really shouldn't be there, whether it's accidental or whether it's malicious. It's not that uncommon for well, one example, if you've got loads of security checks in place, like, for example, certificates validation, you as the developer are going through, you've got to go through a system test environment, a UAT environment, many other test environments before it actually gets out into the field. And it can be a bit of a pain having to jump through all the security hoops, and it adds time. So you can find places where any certificate validation is commented out or it's removed under certain circumstances. The danger then, of course, is that it stays removed out in the field and that security has been lost. Many of you probably come across talks by Troy Hunt from Australia. He was preparing a talk not that long ago, I think, on wanting to demonstrate how to do security properly. And in preparing for that, he wanted to use a bank site as an example of how to do it properly. So he went through, tried his man-in-the-middle attack, just to prove that the security validation was working, and it wasn't. And he contacted the bank quietly and responsibly, and they fixed it and said thank you. And the inference, at least, was that had happened, potentially being removed at some point during a development or a testing process, not being picked up by continuous integration, not being picked up by testing, and made its way out. So this would cover anything that falls under that. Again, making sure your tests cover as much security as possible helps with this, and making sure your continuous integration both works and makes it as easy as possible to deploy to all the different environments, so you don't get developers taking shortcuts. So that's a whistle-stop tour of the top 10, kind of as much as we could fit into 45 minutes. Structurally, I think the conference is working out really nicely in the security track, in that you've now got a few more security talks that are going to dive into more detail where I didn't. So make sure you go along to those if you want a bit more information. I do have a graphic here from a report from earlier this year from Arcsan. Now, this was based on the 2014 top 10, which is the kind of the prevailing one at the time, because the 2016 one's still a release candidate, looking at the most common vulnerabilities. Now, bear in mind, going back to that early mapping, that first one, that's still M3, so it's insecure communication. That last one is now M9 on the new list, which is reverse engineering. And the good news is, Kerry's talk tomorrow covers insecure communication. He also talks a bit about reverse engineering, as I think the Arcsan guys are going to as well. Wait for all the phones to go down. Cool. Moving on from that, we've got, if you do want to dig deeper, you can go back to the OWASP Application Security Verification Standards. If you're dealing with any credit card information, then you need to look at the PCI standards for how to handle that. But the thing I'd like you to take away from this is when it comes to your own security policies, if you don't have one, reference these standards. If you do have one, make sure it gets checked against these standards, especially now with the 2016 details coming out. And if you're writing one or reviewing one, make sure you're referencing this. If you want to improve your general security processes, you've just got to have a general raising of awareness, dig a bit deeper, do some further research, and there's a few different ways in which you can do that. So you can build your in-house expertise, outsource the whole function, bring in specialized security products or specialized security consultants who already know that area in a lot of detail. And in practice, it's usually a combination of the above. And the very last thing is a quick plug for a book. So there'll be a chapter in this on security going into a lot more detail than this. And I'm very pleased to be able to say that we've got one of the other Evolve speakers, Jim Bennett, who's speaking later today, is now going to be an additional author to this. So I can't believe the timing of that. I'm down to about 10 seconds, which means I've probably got no time for questions now, but I will be around. I'll hang around after this. I'll be around for the whole conference at all the evening events, so do feel free to come and grab me if you want to dig any deeper or ask for anything that I haven't covered. Other than that, thank you very much and enjoy the conference.